Hello and welcome to Yeni Science. In this video, I will explain you the setup of a Linux single axis with the XENAX servo-contrôleur. Firstly, we need to connect the servo-contrôleur with the linear motor. Our XENAX is a compact Ethernet servo-contrôleur. Logic and power supply are separated, enabling the linear motor to remain in communication even in case of security-related power interruption. XENAX has TCP/IP and real-time Ethernet technology. The logic supply is always 24-volt DC. The logic consumes about 500 mA. The power supply ranges from 24-volt to 72-volt DC. For larger axes and for higher speed, a 48-volt or a 72-volt DC power supply is recommended. Important is that the power supply has to deliver at least 5 A. In our example, with a smaller axis, 24-volt for the power is sufficient. After setting up the hardware, we open a web browser like Firefox or Internet Explorer and enter the corresponding IP address. You can find this address at the back of the XENAX case. In this example, the address of the Java application ends with 205. With this setup, we get to the WebMotion graphic user interface. If it doesn't start properly, please consult the tutorial video TCP/IP connection. When opened, the WebMotion automatically runs some initial checks. We have two buttons available: Quick Start and Operation. An easy way to check if the axis is running properly is to push the Quick Start button. If power voltage and input functions are okay, move the carried slider by hand over a desired distance. The parameters as well as the current flow through the linear motor are checked. As soon as the Linux Start button lights green, we can start the axis. The reference will be done automatically and the slider of the axis runs the distance we have moved by hand before. The dynamic is adjustable. You can start and stop the linear motor as you wish. The Quick Start function gives you the comforting certainty that everything works properly. That's not bad for one single button, isn't it? Alternatively, you can directly start with the Operation button. When the power is on, it is important that you always first reference the axis. The reference gives you the absolute position of the carried slider, and the electrical commutation of the motor is adjusted perfectly. Now you're ready for testing the motion. For example, go 0. 1 increment is 1 micron. Go position 40,500 increments means to go to the absolute position. With this sample motor LXC85F10, it's exactly in the middle. Repeat reverse is the relative distance from the actual position, forwards and backwards. With the speed override, you can adjust the dynamic, acceleration, and speed. In order to test the accuracy, we will enter a short wait time and go to the motion diagram. After recording and uploading a sample, we can see an overshoot of 20 microns. We can improve the accuracy by increasing the stiffness of the linear motor with the gain position and the state controller functions. Alternatively, if the Linux has a payload, we can also do a fine-tune up and down of the payload. This also has an effect on the overshoot. After the adjustment and uploading a new sample, you can see a clear improvement of the accuracy. You can control the movements not only by click, but also by ASCII commands. For example, go 0 with G0, or go to position 85,000 increments absolute with G85,000. With WA for way, you can put in a relative distance. With RR5, you repeat the most recent move 5 times forwards and backwards. Let's have a closer look at some other WebMotion functions. We might talk about some functions later in further tutorial videos. Float sensing. This is a unique Yeni Science innovation. When running the float sensing, the magnetic catching forces, the payload force, and the friction forces are compensated. The float sensing function is the basis for a precise force measurement or for high stability of speed for scanning processes. The state controller is the core of the closed-loop control and is, because of the communication between servo-controller and linear motor axis, automatically set by the XENAX. The only parameter value you have to set manually is the payload. Another adjustment you can do manually is the fine-tuning. As we have seen before, with gain position you can change the position stiffness. Higher values result in higher precision, but there is a tendency of oscillation and more noise. With gain current, you can reduce the noise. However, please keep in mind that as a result, the precision will decrease as well. With filter frequency, you can adjust the notch filter. If you have an oscillation while running your application, you can remove it with the corresponding filter frequency. With single axis, it's possible to get the frequency by a smartphone app, which detects the corresponding value. Oscillation in a multi-axis configuration is more difficult. Successful is normally a range from 200 to 1000 Hz, but practically speaking, it's more of a trial and error process. The deviation position is the maximum deviation window in increments while the axis is in motion. If the deviation is higher than the value entered, then the error 50 comes up in the digital display of the XENAX. A deviation position value of 0 means that the deviation window is unlimited and no XENAX error will interrupt the motion of the linear motor. This unlimited deviation window allows to adjust the force according to the value of the motion current while no deviation error occurs. Deviation target position means the maximum value of increment when the axis reaches the target position. If the deviation is within this value, then the status in position will show up. In the motor parameters, the I-stop value defines the maximum force, while the linear motor is in stop status. I-run is the max force needed when the motor is in motion. I-run is at least 2 times or more higher than I-stop in order to have enough force for acceleration and deceleration. In all cases, the linear motor is self-protected against overload respectively over temperature. The other parameter values are automatically set by the XENAX servo-contrôleur. The reference operation finds the absolute position and does a precise adjustment of the electrical commutation angle. You can select in which direction you want to start the reference operation. Additionally, there are different methods for gantry references available depending on the motor installation. In the basic settings, there are different operational modes possible. For example, pulse direction control or analog speed value control, etc. Interesting is the mode 10 or higher. In this mode, the input numbers 9 to 12 are used as a binary pointer to a program number. The input number 8 is reserved as a start trigger. Increment per pulse is for the pulse direction control. A value of 5 means that one pulse results in a movement of 5 increments. Sync ratio is used for adjusting the electronic gear ratio between 2 axes. The card identifier is the number for the device, for master-slave or can-open operations. It is showed twice after power on the XENAX display. If you change the card identifier, you have to reference the linear motor again. In version, you find the information about the installed software and hardware version of the electronic board. With update, you can update the installed software. Firmware and WebMotion have to correspond and have to be updated as a pair. See corresponding tutorial. The XENAX servo-contrôleur has 12 digital inputs and 8 digital outputs for the user. In addition to the standard I/O functions for sensor check or for actuator control, it is possible to assign complex functionalities or programs to this digital I/O interface. The outputs are flexibly configurable via software as a sync driver 0 volt or source driver 24 volt. In the I/O box, the inputs 9 to 12 are connected to a binary coded switch with which you can simulate the preselected program numbers. To show you the programming of an input function, we create 2 short indices. The index number contains the acceleration, the speed, and the absolute relative distance of a motion profile. Here we have index 1 with an acceleration of 1 million increment per second square and a speed of 100,000 increments per second with a move to 0. Then we make a copy to index 2 to get the same acceleration and speed as in index 1, but we adjust the motion to 85,000 increments. We assign these 2 indices to input number 1 and input number 2. To input number 3, we assign the reference function. Now we save this program to XENAX. Last but not least, we can run the practice test with the I/O box and see if it runs properly. And surprise, surprise, it does. Once more, ladies and gentlemen, you see how easy the handling of our products is. You're welcome to contact us if you have questions. Thank you for your attention.